example 4 says, is 1 over x minus 3 continuous A at x equals 3 and B at x equals 0? So if we look at this function, it has a asymptote at x equals, a vertical asymptote at x equals 3. So it has infinite discontinuity at x equals 3. So no, it's not at 3. But that's the only place it has discontinuity. So at x equals 0, it's continuous. So it doesn't like just all of a sudden create other places it's not continuous. It would be a specific point where it wouldn't be continuous. So watch out. They could ask you, don't always assume they're asking you on the vertical asymptote. They could just be asking you somewhere else. So be careful of that. Example 5 gives you a piecewise function. And so it says is h of x continuous at x equals 2 and at x equals 3. So let's do at x equals 2 first. So how do we know? Well, first of all, if we know that f of 2 is equal to 1, that's this part down here. To be continuous, you have to have the function exist at the x value. So it does. And now we can't stick just a 2 in here. You see it's undefined. So what we have to do is check the other 2. Does the limit as x approaches 2 from the left exist and equal 1, and from the right? So does a limit exist? And if it does, is it 1? Because it would have to fill in the hole. This is basically filling in the hole, right? Because we know this is a hole right here, or it doesn't exist. So let's just see what happens. If we actually sketch this out, it has a vertical asymptote at 2. So let's just make this 2. And it's got y equals 0 as its horizontal. And so if we were to graph this out, if we put in like 4, it would be 4 over 2, so it would be positive. So this part would be up here, and let's put in like -1. It would be 4 over -3, so it would be negative down here. So that's like a rough, rough sketch. At 0, if you put in 0, it'd be -2, so that's where your 0 is. Okay, so that's what your graph looks like. And sometimes you have to sketch it out to see. So the limit coming from the left of h of x is equal to, by the way, this was h, is equal to -infinity. And the limit as x comes to 2 from the right of h of x is equal to positive infinity. So the limit as x goes to 2 of h of x doesn't exist, and therefore it's not continuous. Now that was for A. Now at 3, look, we're over here at 3, you can see the only place of discontinuity was at 2. So it would be continuous at 3. Okay. You would want to check, though, to make sure, like, 1, at 1, that it had a value or wasn't horizontal or something. Okay. We'll do one more. 6. Is k of x continuous at x equal 2? So let's look at this. First of all, when we're looking at this, we got to go, well, it's not simplified. So it's x plus 2, x minus 2 over x minus 2. So I see immediately that I have a hole at 2. So, and that's all I have at x not equal to 2. It's this. It doesn't say what it is at 2. And I see it has a hole at 2. So this has a removable discontinuity. So the answer is no at x equal 2. Okay. So now, if you wanted to redefine, I'm going to teach you about changing it from that it's not continuous because it's removable to make it continuous. That's why it's called removable. So I could reassign k of x to be x squared minus 4 over x minus 2 at x not equal to 2. And a piecewise, and then I could say that it equals something at x equals 2. And as long as the limit of this is equal to what that is, then I'll have continuity. So what would this would cross out and be a whole. So what would I get if I put it in when I simplified it? I would get 4. So if I said it was 4 at x equals 2, I would have filled it in. And that would have removed the discontinuity. Because this would have been the graph of x plus 2, which is up 2 and over 1. So it's this graph, but it has a hole at negative 2, no, at 2. And then I just filled in the hole, which was 4, and all of a sudden that hole got filled in by this. At x equals 2 equaled 4. Okay? So that's what it means when it's talking about removable and non-removable. If you fixed it and rewrote it as a piecewise and said what it would be, which is equal to the limit, you would have been good. All right, I'll stop there.